fundamental theorem of calculus and definite integrals. If this is the integral of the derivative of this, then we go back to this. Crazy how that works, but we do. Okay? So what we're doing is taking the integral of 3x squared minus 6, basically. Okay, it's not the integral of that. It's the integral of the derivative of that, which goes back to the same thing. So basically, you take 3x squared minus 6 from -1 to 0. Okay? So you could graph it out and find the area under the curve, or you could do this. You take 3 and put the 0 into the function, and then subtract from that, putting -1 into the function. Okay? So what's 3 times 0 squared? 0 minus 6 is -6. Minus -1 squared is 3 times 1 is 3. Minus 3 is -3. So -6 minus a -3 is, or -6, yeah, minus a -3 plus +3 is -3. That's the value of that integral. Okay. How about the cosine of 3x? Well, it's the cosine of 3 pi minus the cosine of 3 times 0. Well, 3 pi, 1 pi, 2 pi, 3 pi. What's the cosine of 3 pi? -1. What's the cosine at 0? 1. -1 minus 1 is -2. Boom. That's fundamental theorem of calculus with definite integrals. Okay, antiderivatives we're going to start with now. Okay, what is the antiderivative of this? Okay, so antiderivatives is you take this and you take the derivative of it, and it should end up with something over there. So this one goes to there, correct? So the antiderivative of this is that. The antiderivative of this is something to the 4th power, because it's going to go up by 1 power. The antiderivative of this is this. So you're going to be finding antiderivatives, okay? So if you take the integral, that's the antiderivative. So instead of being 4x, okay, or take the derivative of this side and work backwards. What gives you 4x plus 5? Well, this does, right? So the antiderivative of that is that, or the integral of that is that, okay? What gives you 3x squared? Well, x cubed does, gives you 3x squared, and so on, okay? So you're starting to get into your mindset of how antiderivatives work, and we're going to hit antiderivatives hard next week, okay? So that's it, not much, okay? So I will throw out some videos and few sets of problems and videos to you, and away you go.